Now we are going to see the exercise problems. In this exercise, the first question is, from the figure, find the area of the quadrilateral ABCD. Here we have a quadrilateral ABCD, and here the length of the diagonal and the length of perpendiculars from the opposite vertices of the diagonals are given. By using these data, we are going to find out the area of this quadrilateral ABCD. Before that, we are going to write down the formula for finding the area of quadrilateral. So, area of a quadrilateral will be equal to half into D into H1 plus H2 square unit. And here we know that the value of D is 18 centimeter. That is, the diagonal's length is 18 centimeter. And after that, we have the perpendiculars from the opposite vertices to the diagonal. So, they are 6 centimeter and 7 centimeter. This means the value of H1 is 6 centimeter and the value of H2 is 7 centimeter. If we want, we can take this 7 centimeter as H1 and this 6 centimeter as H1. And now we are going to find out the area of quadrilateral ABCD. So this is equal to half into the value of D is 18. So this into H1 plus H2. Here the value of H1 is 6 plus H2 is 7. So therefore, if we cancel these two values by using the second table, we get 1 into 2, 2 and 9 into 2, 18. Now 1 into 9 is 9. So this into 6 plus 7, 13 square centimeter. Now we have to multiply this 9 and 13. If we multiply these two values, we get 117 square centimeter. That is, we get the area of the quadrilateral ABCD as 117 square centimeter. This is what the required answer. And now we have the second question. The second question here is, find the area of the quadrilateral whose diagonal and heights are. In the previous problem, they have given us the diagram and we find out the values of D, H1 and H2. But here they have directly given us the values of D, H1 and H2. So it is enough to apply the formula only. First let us write down the formula and then let us substitute the values. That is, the area of the quadrilateral is equal to half into D into H1 plus H2 square units. So this is equal to half into, here the value of D is 15. This into the value of H1 is 5 plus the value of H2 is 4. Now this is equal to half into 15 into 5 plus 4 we get 9. Now we are going to multiply this 1, 15 and 9. If we multiply these three values we get 135 and in the denominator we have this 2. If we divide this 135 by 2 we get the answer as 67.5. So hence the area of the given quadrilateral is 67.5 square centimeter. And similar to the previous problem, we have two more problems. In that, the first one is here. Here the value of D is 10 centimeter, the value of H1 is 8.4 centimeter, and the value of H2 is 6.2 centimeter. As usual, first we have to write down the formula and then we have to substitute the values. First, we are going to write down the formula as the area of the quadrilateral is equal to half into D into H1 plus H2. So this is equal to half into the value of D is 10 and the value of H1 is 8.4 plus the value of H2 is 6.2. Now if we cancel these two values by using the second table, we get 5 into 2, 10 and 1 into 2, 2. Now 1 divided by 1 will be equal to 1, so no need to write that. And 1 into 5 we get 5. So this into, now we have to add these two values. 8.4 plus 6.2 will give us the answer 14.6. Now if we multiply this 5 and this 14.6 we get 73.0 and this 73.0 square centimeter can be written as 73 square centimeter. So hence the area of the given quadrilateral is 73 square centimeter.